Today's video, I want you to please watch yesterday's video first if you have not. I will let you decide if you want to put that on the screen for everybody to watch or watch it on your own. Either way, I woke up at 1 in the morning to do that one. Please watch the video. Okay. What we are talking about today is we are talking about we're going to continue our discussion on similar figures. So similar figures, as you may know, they have congruent angles and proportional sides. Then there's then that's the scale factor. Another way of putting it is it's the constant of proportionality. The constant of proportionality. To get the sides of the dilated figure, right? So we start with the original one and we would multiply it by something to get the new dilated figure. And this is what that means specifically, is if we just wanted to compare perimeters, you would just multiply the perimeter by the scale factor, because that's only talking about lengths. But this is big. So perimeter, you're just going to multiply by the scale factor. If it's the area, you're going to multiply it by the scale factor squared. So let me just show the idea. Like, if we had this rectangle, all we would have to do is multiply this. Multiply the whole thing by 2, right? And we're just adding them up. Multiply by 2, add it up, multiply by 2. That's supposed to be multiplied by 2 and add it up. So we just multiply by 2, right? But if we had the area, we would have the multiply by 2 times the multiply by 2. So that's why it would be, if you do 2 times by 2, that's the same thing as 2 squared. So that's why we square it, is 1 for the length and 1 for the width. Let me show you what I mean with the problems from Delta Math. Okay, so we have these two figures. First thing that you would need to do with these figures, which they will all be, but I just want to show you that this is the case. Notice that we have one angle that's 51, another one is 53, 53, 76, 76. So we know for sure these are similar triangles because the angles are congruent, right? And then it tells us a lot of information. So it says KL is 54. LM is 56 and KM is 68. Then it tells us the next information about the next triangle. OP is 14, NP is 17, and we want to find the perimeter. So we want to know what is this other side, right? And in order to tell what the other side is, we want to be able to make sure that we're lined up with the correct side. So we're comparing the corresponding sides. We'll notice that the side that we don't know is in between 76 and 53. So here's 76 and here's 53. So that means that 54 corresponds. That doesn't mean it's the same. It just means it's in the same location. So corresponding means it's in the same location. So we can find that missing side by doing corresponding parts, right? So we go like this. And you can choose any two numbers from the one on the left. So I'm going to do the ones, I'm going to do 56 is to 54 as, and I chose 56 because it's the one in between 51 and 76. So the side on this figure is 14. So as 14 is to the side we don't know, right? So now we can solve that using proportions, and there are lots of ways of solving it, but my favorite way is to go like this in decimals. Let me clear this out because I was doing stuff with another class. Okay, so we wanted, let me double check because I just forgot. That's how small. Okay, so we have 56 over 54. 56 over 54 equals, and it was 14 over x, equals 14 over x. By the way, Delta Math will show you a different way of doing these, but how I'm showing you still works. Okay, so we get a number that's looks like it's halfway between. It's not clicking on there for me. So it looks like it's 13 and a half. Can you guys see that? Like if I kept on zooming in, I'd get, yeah, 13, and it's halfway between 13 and 14. So X would be 13 and a half. Normally I can click there. Weird. Oh, I wonder if I were to do that the other way around, if I did 54 over 56 and equals X over 14. See how I just flipped them? Hey, yeah, if X is on top, it'll give me that number. Good thing to know. So if we have X on top, it will give me the number when I click on the graph. Nice. So let me switch that. So I am going to change this for the sake of, I want the X on the top, over 14 and 54 over 56. And I got that X was equal to 13.5. But it's only asking me what is the perimeter of that one. So we want to do 14 plus 17 plus 13.5, which I will do in the calculator on here, because this is the calculator that you guys have. And scientific calculator. So I want 17 plus 14 plus my 13.5 that I just figured out. So that's going to be 44.5. Yes. Yay, I got it right. Imagine that. If you want to see another one, I can do another one. I might as well just do another one. So, yes. So we only want one of them. It says that, I'm going to take a picture because I have to draw on it myself. I'm going to do it later. I'll do it afterward. No, I'll do it now. Done. Save to photos. Move it over here into our notes. Slide. There we go. Putting it right here. Okay. Okay, so I want to find another one, and I'm going to label what we have. And if you wanted to do this on your own, you don't have to, I mean, like, doing this on your own, of course you have to do it on your own. I would only draw the parts that are necessary on my paper, or if you can see it in your head, good job for you. I can't. So let's see, RS is 12, SQ is 17, VT is 47, and I want to know UT. So let me just make sure I have everything. Yep, so this is the one, of course this is like this, right? Yeah, so I got from, wait a minute, did I label this? RS is in between right there. Oh wait, UV. Whew. Wow, okay, I wanted this one. I'm like, that doesn't work because we don't have corresponding parts. But we did because I didn't read it right. Okay, so I'm going to do, let's see, making sure. So this side corresponds with that one, and this one corresponds with that one. So I want to make sure that they just are on the same level. So I can have 12 is to 17 as X is to 47. Another way I can do it, if I just wanted to use the calculator in here, is I could do the Maui's hook way. So multiply these and multiply the diagonals and divide by the other one as long as I only have numbers. So I am going to do that. So 47 times 12 divided by 17. And I'm going to do it in here because I can. So scientific calculator. And we're doing 47 multiplied by 12 divided by 17, and round it to the nearest tenth. So that's going to be 33.2. Yes. Yay. Okay. So the next area are these scaled figures. So this rectangle below is dilated by a scale factor of 2. Find the perimeter and the area of the rectangle below, as well as the perimeter and area of the dilated rectangle. express your answer as whole numbers. Okay, so let's start by figuring out the perimeter of the little rectangle, right? So this is one way of finding the perimeter. You can find it however you want to. How I like to do it is I have 2 of the 2 sides that I have. So I'm going to do 16 plus 22. This is my fast shortcut way of doing it. So the perimeter of the given rectangle would be 76. And then we want to find the area. So now the area of that one, of the given rectangle, I'm going to be down here. Yep. So the perimeter of the given rectangle, we're just going to do 22 multiplied by 16, and I get 352. So that's going in the given. So the picture that they have is called the given one, and I got 352. 352. Oh, 2. And now and then it tells us here in the problem that it's dilated by a scale factor of 2. So all I have to do to find the dilated perimeter is I'm going to take my 76 and I'm going to multiply it by the scale factor, which in this case was 2. So the dilated perimeter is 152. 152. But for the area, I'm going to take the original area, so 352, and I'm going to multiply it by that scale factor squared. So, because it's 1 for each length, right? 1 for the length, 1 for the width. So 1408, 1408, 1,408 units. Yes. Cool, and I didn't have to write anything down. But it does a nice little example of that. And I'm going to do one more problem because I can. So this says the triangle below is dilated by a scale factor of 2. Find the perimeter and area. Oh, so we're going to have to remember the area of a triangle. Not too bad, though. So the perimeter is, we're just going to add those numbers up of the given one, right? So I had 15 plus 20 plus 25, and I got 60. So the perimeter is 60. And it says that my scale factor was 2 again. So 60 times by 2 is 120. Now, for the area, you have to do, I'm just reminding you, you're going to multiply the numbers that are connected to the right angle. That little right angle symbol, that's how you know the numbers that you're supposed to multiply. So we're going to multiply them and divide it by 2. So 15 multiplied by 20 divided by 2 for the area. So calculator, 15 multiplied by 20 divided by 2 is 150. 150. And then for the dilated one, we're going to take our 150 and we're going to multiply it by the scale factor, which in our case was 2, squared. So that's 600. Bum, bum, ba-dum. All right. Good luck. Hope you finish everything today. Tomorrow we are going to be having a quiz on yesterday's and today's video to make sure that you guys paid attention in class and worked how you should. So I'm glad you got to this point in the video so you know exactly what to expect tomorrow. And maybe hopefully you read the post where I talked about it too. Okay, good luck.